Good morning to everyone. This is our first Zoom session. We've got a couple people on, and they had some questions because in my Math 104 class, I muted Jordan.
Her mic went out.
I muted Jordan. My Math 104 class was assigned to work on the test in Unit 1, chapter test in the book. And so there were some questions over that. So I'm going to address those on page 103, question number 8. And then I'm going to spend some time on factoring because there are some questions over that. So I'm going to go ahead and share my screen so everybody can see. Hopefully y'all can see the paper okay. Those that are on the live Zoom, there is a menu for you on the Zoom at the bottom. And so there's probably one that says reactions, I think. Yep. So if you have questions, raise your hand or just interrupt me verbally. It doesn't bother me either. And we're going to go ahead and get started. So I'm going to look at number 8 here, try to identify it so those that are watching can see. And we're on page 103. And so it's this problem right here, this one that I have circled right here. So we're going to look at this one right here. So let me get the copy down and get my copy out of the way. I know it's 11, but you can never have enough coffee is what I'm saying. 5, 2. Okay. And don't ever be offended if there's something in my handwriting that you can't read, or if you think I wrote something incorrect, or I do some math incorrect. It's all of your jobs to correct me, because otherwise we would hate for, especially our friends that are watching the recording at home, and then they're like, go through the whole recording and realize I did something wrong. That'd be real bad. Because it happened, right? I'm human, I make mistakes. Okay, so this goes back to, let's just remind ourselves of our order of operations. And when I write it, instead of writing it as PEMDAS all the way down, I write the M and D. Remember how in class we talked about how the M and D, multiply and divide, have the same strength? So I write them on the same row to remind myself that they take equal precedence left to right. And then A and S are the add and subtract, and they take precedence left to right as well. So, and remember when we talked about parentheses in my little video? I don't know if anybody's watched any of my videos yet on Canvas. I'd love some feedback on those. But the P for parentheses also has to do with grouping. And fractions is one of our grouping situations, meaning we have to take care of everything in the numerator first, and then everything in the denominator, and then we can divide top divided by bottom. So looking at the numerator, we have to go in our order. So the only parentheses we have in the numerator right now are basically just, they're like fences. They're just for protection. So there's no actions happening inside them. So there's 2 times in algebra and math where we use parentheses. One is because I want to group things together, some actions. And the other is when I'm just trying to protect something. And right now we're just protecting the -1 and we're protecting the -10. So we're going to go down. There's no exponents, but there is a multiply. So right here, there's an unsaid multiply between the -4 and the -1. And so we're going to make that a +4. And then I'm going to just rewrite this for just a moment. And then I'm just going to continue with the top until we know we've got a final simplified value for that. Is everybody cool with that? And then next in the numerator we have, you could think of this as like a -1 times a -10. That's one way to view it. Or you could say, I'm just taking the opposite of a -10, which is a +10. So this becomes 4 plus 10. And that's 14. And now I'm going to do the same for the denominator. The denominator is nice and much more simple because I don't have any parentheses. The only is just for protection for the -2, no exponents. You could think of this as a -1 times a -2 if you wanted to, or I kind of think of it as it's just the opposite of a -2. And again, math is confusing because we have symbols that do, they say, or I should say, we interpret, right? We all are looking through different lenses. And so we all visualize this depending on our experiences, how our teachers, right, in prior math classes have explained it. So I try to throw out a couple different things in case one sticks with you. So this is like 5 plus 2, which is 7. So now we have 14 divided by 7. So this is how we're saying it to ourselves. 14 divided by 7 is 2. Everybody good with that? Danielle, give me a thumbs up. Jordan, question?
So what I did it wrong. The way that I did it was I times it because I thought that like the 4 next to the parentheses, the 10, I thought that meant you had to times it.
We do. we times a -4 times a -1.
Yeah, the next step though, that next step, not this one, but the next one over the 4, I thought I had to times them right there. Yeah.
Oh, right here?
The 4 minus the -10 in parentheses. Yeah, I thought that parentheses balanced out and that it was going to be 40 and they had to times them. So
I see. So whenever we have a subtraction, you could think of this as like a -1, and that is getting multiplied by the -10.
Okay.
So yeah.
So
Yep.
because the minus is in there, it makes it.
Yes. Yep.
Okay.
So unless the 4 is right next to a parenthesis, it's not a multiplication.
Okay. Thank you.
Great question. Great question. A lot of us, like we said, it's been a while since we've done math, or we've had a few misconceptions, and we're just going to work them out. That's what this class is all about, is supporting you in your 104. Okay. So on that same chapter test, some students were asking about the factoring from 25 to 30. And I am going to tell you right now that factoring is probably the elite of the elite factoring. And so we're just going to go, put a break, pause. We're going to go back to 1.6. Not sure if everybody's seen my videos yet, but I do have a video up in the 084 class for order of operations and exponents. And I have to add them. I thought I did, but I did one for terms and not factoring, but terms, adding and subtracting terms, like terms, and some multiplying. And I will get those up there today. And then I'm going to make a full factoring. I'll have this one up there, but a full factoring video as well for 1.6 for support. So let's go ahead and look at 1.6. And this is all about factoring. Okay. So factoring, it's like, why do we factor? That's a good question. So it all goes down to, why do we do algebra? Okay, so I'm going to just kind of give you I was going to make a video about this, but I think this is a good time to talk about it. And I actually, Danielle stayed for this kind of this similar talk last week. So the reason we do any algebra is because we're trying to solve for a situation, okay? And we are going to have a couple of different situations this semester. We're going to have situations where, all of them are going to be, we're basically solving for X, okay? And I'm going to just break it down, like, I'm just going to give you like a little hint right now. Until you can get X, we want X alone. Anybody that's had kids knows what I'm talking about. Sometimes mom just needs to be alone. I need some alone time. And so X just needs to be by itself. Okay. But for X to be by itself, it can't have anything multiplying out in front. It can't have anything adding to it. And it can't have anything besides a 1 here. And and there's an unsaid 1, right? When we don't write anything, any exponents there's an unsaid 1. This is ideally what X likes to be. That's the same as this. There's nothing besides an unsaid 1 here, right? an unsaid 1 here and a 0 here. It's basically what it's trying to do. And so let's just do a couple little basic solving ones so you can kind of see here. So if I have 2x plus 6 equals 8, right now x, it has a 1 exponent. So that's the start. If there's anything other than a 1 exponent, we have to factor, okay? Because there's an x times an x in there that made that x squared, or x times x times x that made an x cubed, whatever that is. So that's why we have to factor, okay? But if we wanted to solve here, because this is an x to the 1, then we can just start peeling away these things, right? Like mom needs some alone time. We're going to peel away. And so we brought up this order of operation last week. And when we talked about our order of operations, what we just worked on in that problem number 8 from before was we simplified. We went in this direction. But when we solve, we actually go in this direction. We're undoing. So think about when you drive to like a location, or you drive to work, or you drive to church, or you drive to pick up your kids, or you drive to a friend's house, right? And you make certain turns to get there, and you get in your car, you shut the door, you turn on the car, you start driving, you take a right, whatever. But when you go to leave, you're doing the opposite action, right, in reverse order. So you're going to get back in your car, you're turning back on your car, you're going out of the driveway the opposite way that you came, you're going to turn the opposite ways to go back home. Does that make sense? So that's what we're doing when we solve as well, is we're going in the opposite direction, and we're peeling away. So if we added, like right here, we added a 6, to undo that, we have to do the opposite math action. That's why adding and subtraction are together. The opposite action of this addition is subtraction. Okay, so we're going to subtract away that 6. And then next up is we're going to undo any multiplication and division. And there is a multiplication here, right? An unsaid multiplication. And to undo that unsaid multiplication is the opposite action, which is division. So we're going to take 2x and we're going to divide by 2, because that makes a 1. Remember up here I said x to be alone, x wants a 1 in front of it. And so that means we're going to divide by 2 on the right, because our equal sign is a balance. Whatever we do to the left, we have to do to the right. And so x must equal 1. Okay. Now, had there been an exponent other than a 1 here, we would have had to undo that. And that's where that factoring thing comes into play. Okay. So everything about algebra, it's this simple. You're trying to solve for x, and if x doesn't have a 1 there, you're peeling everything away, and then you're trying to peel away that x squared or that x cubed or the x to the 4th, and we're going to learn other ways to do that throughout the semester. So factoring is one of those ways, okay? So I can spend more time on a whole video on solving a bunch of equations, but I wanted to go to the factoring today. So I'm going to be on page 77, if y'all want to turn there so that you can kind of just follow along. I'm going to pick some of these.
I accidentally left my book in cold water.
You what? Left your book at home?
Yes.
No, that's okay. I'm going to write them down so you can. I'm going to pick even ones because I'm not going to have a lot of homework for this class. I will have some things, the forums, you saw that. I am going to start putting together like a few quizzes. That what I'm going to do on those quizzes is they're going to be quizzes that the goal is that you have 100%. You can do them as many times as you want by the end of the semester. Now, I know that you can do stuff at home on your own, but the goal is that you're being honest with yourself and that you're just going to keep working on those until you can get your best grade on those, because I want you just to know how to do all of the basics so that you're supporting that 104 class. So let's look at number 2 here. So I'm going to write this down so that everybody can see which one I'm doing. So basics on factoring. The first thing we always do is we look for GCF, the greatest common factor. And if you watched my video on, well, you haven't because I haven't put it on 084 yet, my video on terms. Terms are things that add and subtract. So this is a term, 12x to the 5th and 18x to the 7th is a term. But factors are things that multiply together. So there's numbers that multiply to make 12. There's x's, 5 of them, that multiply to make this x to the 5th. And then there's numbers that multiply to make 18. And then there's 7 x's that multiply to make this. Those are factors. So we want to look for the greatest common factor between this term and this term. So when I look for factors of 12, I'm thinking of things that multiply to make 12. So I have a 1 and a 12, 2 and a 6, right? 3 and a 4. And if we break it all the way down, it's really a 1 times a 2 times a 3. That's 1 times 2 times 3 is 6 times another 2 is 12. And then if I look at 18, I got 1 and 18, and then I've got 2 and 9, and I've got 3 and 3 are the pairs, right? So this 18 is really 1 and a 2, and then a 3 and a 3. And you might already be able to see that, oh, I didn't even, no, 18 isn't 3 and 3, 18 is 3 and 6. That's what I meant to say. So you might already see right off the bat that 6 is the biggest number that can be factored or pulled out of both 12 and 18. And you can see that because if I look at my raw factors right here, 1, 2, and 3 are in both 12 and 18, right? 1 times 2 times 3 are in both 12 and 18. So 6. So 6 is going to come out front. Sorry, my allergies today. Is everybody with me on that so far? Okay, so when I take 12 and divide by 6, I have 2 left. So I'm going to create a parenthesis here. So everything that's in common is going to come out front. That's what I'm factoring out. And then whatever's left over has to stay on the inside. So 12 divided by 6 is a 2. And then this first term had 5 x's, right? And this term had 7. So they have 5 in common. So 5 can come out because that's what they both share. We're looking for everything that they both share. So this first term doesn't have any x's left. Everything it shared with, it's got in common. And then the 18, when we divided by the 6, we had a 3 left over. And of the 7 x's, 5 of them came out front to represent, so it has 2 left over. So in our 104 class last week, we did some multiplying together. And in my multiplying and term video that I'm putting up, I show again how to multiply. It's called the distributive property over multiplication, because this, right, is right next to a parentheses like Danielle asked earlier. So it is a multiplication. So when I take 6x to the 5th and multiply it by 2, I should get back this original term right here. And when I take 6x to the 5th and multiply it by 3x squared, I should get back to this original term right here. Is everybody with me so far? So when after we did our greatest common factor, which we did, then I'm going to look to see if any x terms have exponent greater than 1. These are kind of my steps on factoring. I have a cool diagram. I'm just writing down that I want to find it and get it to you all. I'll put it up on the on the Canvas site. So inside here, I still have this x squared term, right? And since I do, I would try to see if this fits into one of my strategies for factoring. And I'm going to tell you that it doesn't. So we're gonna do more factoring as we go. And so we're going to ask ourselves, how many terms is the question? And if there are 2 terms, this is just me kind of writing, but I'm going to get you a fancy one here in a bit. So if there are 2 terms left, so how many terms in here? So I have 2 terms. There's only a couple of options that we could have to, if we wanted to factor this more. And it could be a difference of 2 squares, but it's not this because that's an addition, so that's not going to work. It could be a sum, and it is a sum of 2 cubes, but this is an x squared, so that cancels that out. It's not 2 cubes. And it could be a difference of 2 cubes. Okay, so let me just give you like, I'm not going to factor them, but I'm going to show you what would a difference of 2 squares look like, just so you know. X squared minus 9, that's a difference of 2 squares because x is squared and 3 squared makes 9. So that's what a difference of 2 squares looks like. And these are, they're in the lesson in here too. They're the good diagram. They don't give it in this book, but they do go through all these things. These are just the questions that you're going to ask yourself when you're factoring. And an example of sum of 2 cubes would be a sum, right? It has to be a sum. And then something cubed, like x cubed, and then something else cubed. So 27 is 3 cubed. So that would be a sum, an adding of 2 cubes. And we already know that's not this one up here because that's an x squared. So that's out. And then a difference of 2 cubes would be just like this, x cubed minus 27, because 27 is 3 cubed. So it's not any of these. I'm just letting you know this is all done, but I'm showing you why it's all done. So that's I think the biggest hang up that a lot of students have is they don't know, like, when am I done, right?
Yeah, I'm still lost. I'm still on. I wrote down difference of squares, difference of sum, difference of cubes, don't know what they mean, and don't know why any of those numbers are below there. I'm still lost.
That's all right. So that goes back to what I just said. Students want to know, like, how do I know when I'm done factoring? Like, I don't even know where to keep going or what any of it means. Like you said, Dania, I don't know. So we did our greatest common factor, and it's like, well, how do I know that I can't do any more, right? And so that's what I'm looking for. If I have 2 terms, which I do, the way I'm going to know that I'm done is
How
I'm
do I
gonna
know?
look.
How do I know I have two terms? What are the two terms?
Oh, two terms. Terms are things that add or subtract. So I have one term here. A term is a number, a value, or a letter that gets multiplied together, or it can be by itself. So two is a term, that's one term. And then this is a term.
But so they're terms because they have to be times by the 6x to the fifth
No,
power.
they're terms because they're being added together.
Okay.
Yep, any number or letters that are being added together are terms. But these are great questions. It's a lot of new lingo. So this up here is our original term because it was added to this original term.
What?
It's okay, it's okay. Terms are things that are added or subtracted. And we can't, these are not like terms. Oh, there's a deer right out in front of my office. It's so pretty. Oh, there's two. They're not like terms. I call them like families because they're not from the same family. This is the X to the fifth family, and this is the X to the seventh family. So they can hang out. They're like cousins, but they just can't, we can't add the 5, the 12 and the 18. Does that make sense? Because I don't have, they're not from the same family. They're like from the X genealogy, but this is the X to the fifth family. This is the X to the seventh family. They have some things in common, right? This is what they have in common, 6x to the fifth. And then once we pull away everything that's in common, this is what's left over.
Okay.
Okay. So to find out if I'm done is I'm going to exhaust all my possibilities. If what's left over inside the parentheses is an X that is more than a 1, which it is, then there's only 3 possibilities it could be, okay? One of them is a difference of 2 squares. A difference, meaning there has to be a subtraction, which there's not. And the two things are subtracting. One has to be a square of something, a perfect square, like 2 squared is 4, or 3 squared is 9, or 4 squared is 16. It has to be a perfect square subtracting another perfect square. Well, we know it can't be that because it's an addition, so that's already out. So we know that this is not 1.
Okay. Okay. So you're saying like if it were a 3 and a 9 instead of a 2 and a 3, then you could divide it 4.
Right. Yep. And because right, and 2 is not a perfect square or something anyway, so it's kind of out.
Okay.
Then my other option is a sum of 2 cubes. I'm like, oh, I do have a sum I'm adding, but the things I'm adding are not cubes because it's an X squared. It would have to be an X cubed.
So if there's a 3, it's cubed then, is what that means?
Nope. If this were this thing here, okay, I'm looking for the 3 possibilities. If I could do anything else with this, it has to be one of these 3 possibilities.
Yeah. What's a cube though?
Oh, a cube is something to the 3rd power.
Oh, okay. Okay. Yeah.
That's okay. And so it would have to be this, and it's an X squared, so I know it can't be this anyway, even though it's adding. Okay, so that's out. And then this one is a difference, but we don't have a subtraction. And it's a cube as well. And so because it's not a cube, it can't be any of these 3. So we know we're done.
Okay.
That's as far as we can go. Okay. And then I'm just going to write myself a note here, down here. If it does not fit any of these 3, we are done. So we're done for number 2. I know it's a big explanation for number 2, but I want students, that's where students, I think, get the most hung up. At least for me, it was like, how do I know I'm done? Because I don't know enough to know. So that's what we're looking for, okay? So let's do another one. Let's look at number 12. So number 12 says 2x cubed minus 14x squared plus 20x. Okay, so I'm going to, first thing, I'm going to find the greatest common factor. And so 2, the only thing that could divide from each of these is a 2, because that's the smallest thing I have here. So I think they are all even, so I can divide them each by a 2. So I'm going to start my parentheses. So divide that by 2, I'm just left, that's going to just be a 1, right? And then before I start doing that, I can see that they each have at least one x, right? So that's the most I can take out. You can only take out the most that everybody shares in common. So when I do that, 2 divided by 2 is 1, and then I take out one of the x's, so I have x squared left over here. And I do want to remind everyone, we have 3 terms when we started. 1, 2, 3. These are all, we have 3 terms, 3 groups of things that are being added or subtracted. Everybody with me that? Okay. So that means when I pull out what's in common, I still should have 3 terms left over. It's just what's remaining from each term. So I have an x squared left from the first term after this is pulled out what's in common. So now I'm still subtracting. 14 divided by 2 is 7. And I have 1x left over. Everybody's good with that? And then plus 20 divided by 2 is a 10. And I took the only x I had, right? Okay. So I still have 3 terms. They're just simplified with what's out here. So I found my greatest common factor. So my greatest common factor is 2x, just to let myself know that. And now I'm going to ask myself the question, how many terms? 3. And so I have 3 left. And really, I said the second question was really, do we have any x's that have an exponent greater than 1? And we do. So that's why I'm like, okay, maybe I'm not done yet, because I can only be done if I'm down to just an x to the 1 somewhere. Okay. So I have 3 terms left. So last time we had 2 terms. And we knew that these were the only things that were possible if I could factor this, were these ways. Now we have 3 terms, and now the only way we can factor this is into 2, let's just write this, only possibility is, I want to make sure I'm getting the same wording that they give in our book here. Is going to be something like on page 71 if you turn there, but only possibility is going to be a something times a something, and they're going to be 2 terms times 2 terms. And so I'm going to put you through, I'm going to kind of guide you through this. It's going to be x something and x something, because x times x makes this x squared. Okay, so we have to figure it out here. Now, so this is a guess and check way. So I'm going to say, I'm looking for factors of 10. Okay, so I'm going to list all my pairs that make 10. So I've got 1 and -10. I've got a -1 and 1 and +10, a -1 and -10. 2 and 5, and a -2 and a -5. And I'm going to say now add pairs. So we've got 11, a -11, 7, and a -7. And we need a -7 right here. So we need factors, things that multiply to make this one, that add to make this one. And does everybody see where this is the pair? Because we get the -7. So x -2 times
I thought a negative times a negative made it a positive.
it does. That's the uniqueness. They multiply to make the +10, but when you add them, they make a -7.
Oh,
That's okay. And I'm irritated at myself because I don't have that video up yet that I already made on how to multiply these. That's what is up there. So you'll probably want to go back and watch that. So now I'm just going to check my answer. Okay. So when I check my answer here, I'm going to multiply those together. So I get x squared. I'm going to multiply these together. So I get -5x. This is like FOIL, if you've used FOIL before. And then I'm going to multiply my inside. So I get a -2x. And then my last. So I get a +10. And so my 2 terms times 2 terms multiplied to make 4 combinations. So that would be 2 times 2 is 4 combinations. And then these are like terms. So that's why we can simplify them. So you have x squared and then -7x plus 10. And then obviously the 2x from the beginning. So the full factor. So let's just write final answer is the 2x that we factored out from the beginning, and then the x -2 and the x -5. And you could have 2x, and you could have written the x -5 first. That's okay. Multiplication is commutative, like 2 times 5 and 5 times 2 are the same thing. So they commute back and forth either way. Is that helping everybody on kind of get through some of those? Okay. Now,
Oh, real quick though, how come we leave it like the x -2 and the x -5? Like we don't put the check my answer thing.
How what?
How come we don't put what you got for check my answer?
Well, I'm just checking my answer to make sure when we multiply these back together, do we get our original thing?
Okay, okay.
So I'm looking to get everything down to where x has a 1, x has a 1, x has a 1, if I can. And now since all my x's have a 1 exponent, I know I can't factor anymore.
Okay.
So that's the key. Let's make ourselves a note. Once we know that all of our x terms have only a 1 exponent, we cannot factor anymore. Just got to keep my eye on the time for my other class. Everybody with me so far? Okay. So let's do a little bit trickier one. Let's do I want to get a good one with the squares. Okay, let's do number 14. This will get me one in the meantime. 14 is focusing here. Okay. Okay. So 14 seems like, oh, darn it. Where am I focusing? So on 14, I was waiting for it to focus. On 14, we are looking at this going, X and Y have only a 1 on them. So why can we not just be done? But I always look to see for my greatest common factor. And these are my terms that are being separated. So this is a term and this is a term. Just kind of reiterating all the lingo, the language that we've been learning. So I can see that the 3 and the 7 don't have any factors in common. And the A and the B, they don't have any letters in common. But I have this X minus Y thing, and I have, this guy has an X minus Y thing, right? So the X minus Y is the greatest common factor. So when I pull the X minus Y, and because it's a whole X minus Y, I have to put it in parentheses. When I pull the X minus Y out, I'm looking to see what I have left over. And I have a 3A left over. And then I have a minus 7B left over. And now, because everything has a 1 exponent, it's as far as I can go. And now I'm down to only things that multiply, because this thing is multiplied by this thing. Right? So I'm done. I really want to find a good difference of squares, but okay. So let's do okay. So let's look at number 4 would be another good one to just try and think our see if we can use some of our strategies here. Okay, so I'm looking for my greatest common factor. And between 8 and 24, they both divide by 8, right? So that's nice if we can do that. So 8 is going to come out. So I'm going to just write 8. And then we got 4y's here and 2y's, right? Y to the fourth and y squared. So y squared is going to be the largest there. So I'm just going to write that over here. That's my greatest common factor. Okay, so when I do that, when I pull out 8y squared, 24 divided by 8 is 3. And then I have y squared left over. Because I have to just check and make sure y squared times y squared would make a y to the fourth. Subtracting, and then 8y squared was, it had everything in common, right? So I have to have a placeholder, so I have to have a 1 there. Okay, so that's my step 1. So step 2 is because 3y squared has exponent of 2, I have to investigate. And so the next question I have to ask is, how many terms? And there are 2 terms, right? I have this term and this term. So I'm going back to my original question when I had 2 terms, right? So a possibility is the difference of 2 squares. So I do have a difference this time, right? So this is a possibility. And y is squared. This is good. And 1 times 1 is 1 squared, but 3 is not a perfect square, right? If it was 9, 9 is a perfect square of 3, but 3 is not a perfect square. So I'm done. It is not the cubes, because we already know we don't have an x squared. We have x squared and not an x cubed or a y squared. So does not fit any of the 2-term possibilities. So we're done. And I want to remind everyone, when we're factoring, we're looking for integers. So if things are, the reason this has to be a perfect square is because we have to have an integer. So like 4 is a perfect square of 2, or 36 is a perfect square of 6. I can take the square root of 3 on my calculator, but it's an irrational number. It's going to be some decimal. And so for factoring purposes, it always has to be an integer. And so when we go to start solving equations, there's no equal here, so we're not trying to solve for y, but when we do get to that point, we can solve for 3. It'll be a decimal. Well, we can solve for y here. We will get a decimal answer, but for factoring purposes, it has to be an integer. Okay. So let's see. We did that one. We did that one. Okay, so I'm going to give you I'm going to give you a new one. This is just my own little example. I'm going to make up, and we're going to say 25b squared minus 36. Okay, so my first question is always, what is the greatest common factor? And do 25 and 36 have any common factors? So 25 has 5 and 5, right? And then 36 has 6 and 6. But 5 is not at all a factor of 36, and that's really my only factor. So there's nothing between 25 and 36, and then b squared, there's no variables on 36. So the greatest common factor here is 1. Okay. So my next question is, okay, so that there's no greatest common factor. But then I'm like, but because b has exponent of 2, we have to investigate. Okay, so we're going to investigate. So can anybody guess what my question is going to be? I keep asking.
How many terms?
How many terms? Good job. So how many terms do we have? I just didn't hear that. No, she didn't answer. It's okay. Jordan, do you know how many terms we have?
Don't we have 2?
Yay. Terms are things that are added or subtracted. So we have a term here and we have a term here. You're always looking for the adding or subtraction in between them. So we have 2 terms. Okay. So if we go back to our possibilities for 2 terms, there's only 3 of them. 2 of them involve something cubed. And that's not us, right? Because ours is something squared. So the only possibility is the difference of 2 squares. So I'm just going to write only possibility is difference of 2 squares. So we do have a difference, right? Okay, so we have the difference. I'm going to check box there. And then we have 5 squared. And we have 6 squared. So I'm just going to rewrite it. We have 5 squared b squared minus 6 squared. And this is, we really want to write it like this, 5b squared minus 6 squared. And I'm going to point to where this is in the book so that everybody, this is page 73 in your book. So a difference of 2 squares is if A is 5b and b is 6, our difference of 2 squares is a squared minus b squared. And that's what we have. We have something squared minus something else squared. Then, since we have that, the rule says that we can factor this into a minus b and a plus b. And I will show you, we'll check our answer and I'll show you why it works. Okay, so ours is going to be 5b minus 6 times 5b plus 6.
Where did you get A from? I'm lost.
It's just the letters that they use for the rule. So this could have been X and Y. We could have named these X and Y, and then this would be X It's just something squared minus something squared. I'm just using them to represent the pattern. So we know what the pattern will look like. I know because the letters in my problem are B. That's what's confusing.
So is that like the technically considered like the formula?
Yeah. So because this fit our difference of squares, we had something squared minus something squared. The pattern, then the way it factors is into the one something minus one and the one something plus the other one. So this is just a pattern of how it works out.
Okay.
So we could have let it represent it. We could have said, here's our one something squared minus the other. And so it's x minus y times x plus y. It's just the book uses the letters A and B, and it got confusing, Danielle, because B is already in our problem. So I think that confused you a little bit. So let's just prove that this worked. Let's just check. So to check our work, we're going to multiply these. We're going to use FOIL. So 5b times 5b is 25b squared. And then 5b times 6 is plus 30b. And then minus 6 times 5b is minus 30b. And then minus 6 times 6 is a minus 36. So this is the unique situation where these four multiplications, they created four products, four things that got multiplied together. But then when we add like terms, notice what happens uniquely, those add to 0. So that's how you're ending up with the 25b squared minus 36. So I'm giving that a check. So here's our final answer, the 5b minus 6 and 5b plus 6. So we good with that one so far? Okay. Now, hopefully some of these are going to help you when you go to keep working on that chapter 1 review, that chapter 1 test, because there's some factoring in there. I'm just going to go back to that. So those 25 through 30 on page 103, some of these will start working out. You'll see a difference of squares maybe going through these strategies here. So let's go to 25 to 30 on the test, because this was just for practice. I just wanted everybody to work on these. So chapter 1 test, page 103. And let's go to number 25. 12x to the 4th minus 26x squared minus 10. Okay. So they asked us to factor completely. So the first thing we're going to do is try to find our greatest common factor. Anybody come up with a greatest common factor?
All I could think of was 2.
Yeah, 2. There's no X's in common, right? Okay, so 2 is going to come out front. So 12 divided by 2 is 6. And then we have X to the 4th minus 13 X squared minus 5.
How comes we don't make it 2x squared and then it goes 6x squared minus 13 minus 5? Or 13x minus 5?
Oh, because they didn't have an X in common, so it stays the X to the 4th.
I thought the x to the 4th, the x to the 2, I thought the 4 could be divided by 2 though. Like you could make it smaller still.
Well, we could only if there was some X's in the on the 10 that we could pull out too. So we are going to be able to factor this further, but just my greatest common factor, the 10 didn't have any. So we're at our next step. So my next step is we have to investigate. And that's because we have X to the 4th and X squared. So they're both bigger than 1. So we have to try and see if there's something else we can do here. Everybody with me so far? Okay, so because we have 3 terms, that's what we're asking, how many terms? Then we must have something, it must be like something and something. Okay. So the only way we could have an X times an X to the 3rd. But we have to remember when we have our FOIL thing, right? When we FOIL, we always have 2 terms that are like terms. And they add to make this in the middle. So they would have to be X squared terms to do that, to add to make this middle guy. So this has to be a something X squared and a something X squared. Because X squared times X, we're always thinking about the FOIL because it's kind of a guess and check at this point. So a X squared times X squared will get me to an X to the 4th. So that's the idea. Now, before on the example that we did together, on number 12 here, right? This is a 1 on the X squared, so it was nice and easy. We know it was just going to be X and X. But this one's a little bit different because it's a 6. So we could have different factors that make 6. So it could just be a 1 and a 6, or it could be a 2 and a 3.
I have a question.
Sure.
In between the 12x and the 26, isn't that supposed to be a plus sign right there?
Oh, good question. Oh, it is. Thank you. Oh my gosh, thank you. That'll change things later. Thank you, Jordan.
Sorry,
Okay.
I just
No, don't be sorry. I told you, interrupt me, because otherwise we would have gotten stuck. Things wouldn't have worked out. Okay. So we need to think about how if we were, once we get these two binomials factored out, they have to multiply back to this 6x to the fourth plus 13x squared minus 5. That's the key.
Why'd you go with
Go.
Why'd you go with 2 and 3 instead of 1 and 6?
Well, we could try 1 and 6.
Oh, it doesn't
But,
matter.
It will eventually. So let's just do a guess and check of just 1x squared and 6x squared. Okay. So before we looked at things that multiplied to make 5, a negative 5 on our other example, and they had to add to make this thing in the middle. But now we've got this complicated thing, right? So I'm just going to throw out, so just don't write anything down. I'm going to throw out some possibilities. So let's say we did the 1x and a 6. That makes our 6x to the fourth, right, on our FOIL. And we need something to be a negative 5. So this could be a 1 and a negative 5, right? But when I do that, I've got to think about my middle terms. My middle terms that are going to add, it's going to be a 6x squared and a negative 5x squared. That will add to 1. But ours is a 13. So that combination in particular isn't going to work. That's okay. This doing lots of guess and check will help you go, okay, now I'm starting to see more of a pattern. So that won't work. But what if we had 1x squared? Math is definitely about just like trying things and being okay being wrong, and then just trying something else. That's half of what math is about. So that didn't work. But what if I had the minus 5 here? I'm going to have a minus 30x squared and then a plus 1 and that x squared, and that will be a negative 29x squared. And that's not the right number, is it? We need 13. So that's not going to work either. And even if I would have made this a minus 1 and this a plus 5, it would have just made it a negative 1. So that those aren't going to work. So I'm going to go back to the 2s and 3s. And the cool thing is there's only one way to make 5, 1 and 5. So I don't have a lot of combinations, right? So I'm going to try, I'm just going to do my guess and check over here. So 2x squared something, 3x squared and something. So it has to be the 1 and the 5, right? So I'm going to try a minus 1 and a positive 5 and see what we get. So we get a minus 3x squared with that combination, right? And a plus 10x squared with that combination. Not quite big enough. It adds to 7x squared. So we see that not quite big enough. And that's unfortunate because the 10 and the 3 itself adds the 13, but they're opposite signs. So that's not going to be big enough. So what if we flip-flop the 5 and the 1? If we make the 1 the positive and the 5 the negative, it's just going to make this a negative 7, right? So that's not going to work. We need to flip-flop them. So let's try it as 2x squared plus 5 and 3x squared minus 1. Let's see if this works. So now I've got 15x squared minus 2x squared. Do they add to make our 13x squared? Yay, they do. That is so exciting. Highlight it, circle it, put it in colors, and it goes with this 2 up here. So we still have the 2 that we factored at the beginning, our greatest common factor. And then we have 2x squared plus 5 and 3x squared minus 1. And are we done?
No, because there's still two x's.
Because there's an x squared and an x squared, right? We have to investigate. Doesn't mean we're not done, but we just have to investigate. So our only possibilities, because there's two terms, right? And they're squares, is the difference of squares. This is the only possibility it could be. Well, that's a sum. So that's done. That's done, that's done, right? And this is a difference, but 3 is not a perfect square, so we know we're done. Good question, good question.
I have to go because I have my other class.
Okie dokie, artichoke.
Well, thank you.
You're welcome. We'll see you in class on Thursday for Math 104.
Yep.
Okay, bye, darling. So that's 25. So let's try one I know we haven't done yet. And that would be the 28. That's a trickier one because we haven't really done anything with fractions. Okay. So our first question is always the greatest common factor. Did we find anything that we can factor from the two terms?
Just one, if that,
Yeah.
I'm not sure.
Wah, wah, wah. Okay, so we're off to the next thing. We know you got to try to factor because we have something bigger than a 1, right? So we have to investigate. And it's always good to write down why we know we have to investigate. We have to investigate because the 2, 3, right? It's bigger than 1. Okay. So our question is, how many terms two? Yeah, you got it. So there's 2 terms, 1, 2. And this time we have the cubes, right? We have something that's cubed. So let's go to our list. Here's our list. It's not a difference of squares because this time we have the cubes. So it could be one of these. And ours is an addition, so it's a sum. So it's going to be the sum of 2 cubes. Sum of 2. Well, we have to make sure we've got cubes, right? So we've got t is cubed plus. Can we make a cube out of 1/8?
I don't know.
That's okay. So this thing that's focusing is driving me crazy. 8 itself is a cube of 3. So 1/8 is the cube of 1/2.
How do you get that though?
What, hon?
How do you get that?
So I'm gonna show you.
And then
Yep.
the 2 is supposed to be, okay, no, you're good, okay.
I'm going to show you how, without having to stress about having to know all this, I'm going to show you in the free Desmos account. I haven't opened anything up yet today. Let me open up my Desmos. gosh, all this new stuff, it's like, what email did I use? It's ridiculous. Oh, gosh. I wish it wasn't that.
Say you had to put a period.
Okay, so we want to be able to quickly know, can I make a perfect square? Can I make a perfect cube? In this case, we're trying to see if we can make a cube out of 1/8. So what I'm going to do is I'm just going to go here and I'm going to go down to my keyboard and the general cube root is, let's see if we can find one under functions. Right here. I'm gonna click on this one. It says n root, the n root. And see where it's letting me put, instead of a 2, I'm gonna put a cubed root. I want to see if I can make a cubed root of underneath there, 1 divided by 8. And if I click on 1/2, I can see up here, I can click on this little blue, and the blue, click on the fraction, it'll put it in fraction form. It'll tell me the cubed root. So essentially, I can say 1/2 parenthesis, and then if I want to make an exponent, I can either use my exponent down here, this a to the b, or I can say shift in my 6 key with the caret and put a 3 there, and I can validate that it does. The cube of 1/2 is 1/8. And if it didn't, then I know that it's not I can't make it into the sum of 2 cubes.
Okay, it's like a way to double check.
Yeah. It's a lot of guess and check and being okay that you're not correct yet. Okay, so now that we've proved this, then we have our rule. Okay, so our rule is on a page. I just want to make sure everybody knows. Oh, whoops, I got one. Oops. We'll go back here. Where did it go? The rule is on page 76. I think. Where did they put it? Oh, yeah, on page 75. Okay. So this is what it looks like on page 75 right here. So if it's the sum of 2 things that are cubed, it's going to look like this. We're going to add the 2 things, and then we're going to say the thing a squared minus the 2 things multiplied plus the thing b squared. I'm going to write it again. So it's going to be, if we have a cubed plus b cubed, it's a plus b times a squared minus a times b plus b squared. So my a and b are t and 1/2. So I've got t plus 1/2 and then we've got t squared, because I'm just taking t squared, it says, and then minus, deal with this today, the 2 things multiplied. So minus 1/2 times t, and then the b squared, so 1/2 squared is 1/4. So it's going to be plus 1/4.
Okay, like cut me out for a minute. Hold on. It just like signed me out and signed me back in. And like,
No, that's okay.
all right, let me write all that down.
Yeah, write it all down and then I can answer questions. And then I get to go to class.
Okay. Okay. How did you get a 4?
How did I get one forward?
Oh, okay. See, now I have to square it. Okay.
Yep.
Okay. Why
So,
did you? Oh, okay. 'Cause it's just wrong. Okay.
and then this is just the rule. Yep. And
Yep.
because this is the rule, we know we can't factor this thing any further, even though that's a T squared, because it's the rule. It's like, this is done.
So this is the final answer then.
Yep. Yep. So this is a sum of 2 cubes. Sum of 2 cubes.
Okay.
Yeah.
I downloaded a quick question. It's not really about this though.
Okay. Just let me put I will catch you all. I'll let you know if I can do another live session this week for a night session. I will reach out to everyone and let me know if there's other things you want videos of. I'm going to continue making some support videos that I will keep putting out into the various chapters. Have a great day.